Okay, so imagine this for a moment. A planet, not dying on the surface, but from the inside. Its core, still there, still liquid, and yet silent. Because what you're about to hear isn't science fiction, it's real, measured, recorded, confirmed, and still not fully understood. Number 8. Mars, a planet that lost its heartbeat. In November 2018, a spacecraft touched down on Mars, NASA's InSight lander. Its mission wasn't to take pictures, it was to listen, to place seismometers on the surface and hear the planet's internal activity. Over 4 years, it detected more than 1,300 Marsquakes, and what those vibrations revealed was unsettling. Mars is almost dead inside. Not completely, but close. Beneath its surface, under ancient craters and massive volcanoes, lies a core about 1,830 kilometers in radius, nearly half the planet. And here's the contradiction. That core is still liquid, mostly iron, mixed with sulfur and lighter elements. By all our models, it should be active. It should be moving, circulating, generating a magnetic field. But it doesn't. Mars has no global magnetic shield. And that changes everything. Because without that field, solar radiation strips away the atmosphere. Water disappears. The surface becomes exposed, hostile. And yet, we know Mars wasn't always like this. Ancient rocks still carry magnetic signatures, proof that billions of years ago, Mars had a strong magnetic field, a thicker atmosphere, possibly even liquid water, everything it needed to be something else. So what happened? The dynamo simply stopped. Maybe the core cooled too much. Maybe massive impacts disrupted its motion. Maybe its chemical composition changed how heat moved inside it. But no explanation is complete. And that leads to a question that feels a little too close. If a planet can die from the inside, how long until ours does? Number 7. Mercury, the planet with too much core. Now imagine a planet where the inside takes up almost everything. When NASA's Messenger spacecraft entered orbit around Mercury in 2011, it confirmed something strange. Mercury's core is enormous. About 85% of the planet's radius, 70% of its mass. That shouldn't happen. Rocky planets aren't built like that. Earth, Venus, Mars, they all follow a pattern, a core surrounded by a thick mantle, balanced. But Mercury is different. Too much metal, not enough rock. And it gets stranger. Its core isn't simple. Data suggests multiple layers, a liquid iron region, possibly surrounded by a solid shell, and maybe even an inner core, a structure we don't see anywhere else. And despite its size, Mercury still has a magnetic field, weak but real, which shouldn't happen so close to the sun with so much tidal stress. So how did it form? One idea, a massive collision, something violent enough to strip away its outer layers, leaving the metal behind. But simulations struggle to recreate that. Other theories suggest intense solar radiation or unusual material in the early solar system. None fully explain it. Mercury is a planet that looks like it survived something catastrophic, and we still don't know what. Number 6. Venus, Earth's twin that became a nightmare. Venus should be familiar. Same size, similar mass, a similar internal structure, almost a twin of Earth. But on the surface, it's something else entirely. Temperatures hot enough to melt lead, pressure strong enough to crush a submarine. And beneath that surface, something doesn't add up. Based on everything we know, Venus should have a molten core, a convecting interior. It should generate a magnetic field, but it doesn't. Nothing. No global magnetism, no protection. Which makes no sense. Even with its slow rotation, the core should still produce something, unless it isn't behaving the way we expect. There's more. The surface of Venus appears to have been completely reshaped about 500 million years ago, a global resurfacing event, as if the planet released its internal heat all at once, melting, reforming, resetting everything. Unlike Earth, which releases heat gradually through plate tectonics, Venus might do it in bursts, violent ones. But we don't know how that connects to its silent core or its missing magnetic field. Venus shows us something unsettling, that two nearly identical planets can end up completely different. Number 5. Earth, the world we still don't understand. Now let's come back to the only planet we truly know, or at least the one we live on. In 1960, a massive earthquake in Chile sent shockwaves through the entire planet, and scientists realized something. Those waves could reveal what lies beneath us, like a scan, like a map of the invisible. And what they found was unexpected. At the center of Earth, there is a solid core, a sphere of iron and nickel about 1,200 kilometers wide, surrounded by a liquid outer core, a churning ocean of metal thousands of kilometers thick. That motion creates our magnetic field, protecting everything. But here's where it gets strange. The inner core is spinning, slightly faster than the rest of the planet, and recent data suggests it might be changing speed, possibly even reversing. There are also signs of a deeper layer, an inner core, with a different structure, which means Earth's center isn't static, it's dynamic, evolving, unstable in ways we don't fully understand. We've explored space, we've reached distant planets, but 6,000 kilometers beneath our feet remains one of the most unknown places we know. Number 4. Saturn, the planet that shouldn't be this complex. Saturn looks simple, light, smooth, almost calm, but inside, it's anything but. It's so low in density, it could float in water. And yet, it radiates more energy than it receives. Something inside is generating heat. For years, scientists believed Saturn had a solid core, but new data suggests something different. A fuzzy core, no clear boundary, just a gradual mix of rock, ice, and hydrogen, blended together, which shouldn't happen. And deeper inside, hydrogen transforms. Under extreme pressure, it becomes metallic, a liquid metal, flowing like an ocean, generating a magnetic field, a state of matter we barely understand. Saturn may look simple, but its interior is one of the most complex structures in the solar system. Number 3. Uranus, the planet that broke the rules. Uranus doesn't behave like a normal planet. It spins on its side, completely tilted, as if something knocked it over. But that's not the real mystery. The real mystery is inside. Uranus produces almost no internal heat, which shouldn't be possible. Planets like it are supposed to radiate energy, but Uranus doesn't. It's cold, too cold, and its magnetic field is completely misaligned, offset, uneven, which suggests it's not coming from the core, but from somewhere else, possibly a layer of exotic material, something called superionic ice, a state where water becomes partially solid and partially conductive, like a strange hybrid of crystal and liquid metal. But even that doesn't explain everything. Why is Uranus so cold? Why is it tilted so far? Why is it so different from Neptune? We don't know. Number 2. Neptune, a storm powered by something unseen. Neptune is far from the sun, cold, dark, distant. It should be quiet, but it isn't. It's the most violent atmosphere in the solar system, winds reaching over 2,000 kilometers per hour, storms the size of Earth. driven from within. Neptune produces far more energy than it receives, which means something inside is generating heat. One idea is diamond rain, carbon under pressure forming diamonds, falling through the mantle, releasing energy. It sounds unreal, but experiments suggest it's possible. Still, it's not enough. No single explanation fully works, and the biggest question remains: why Neptune and not Uranus? Two similar planets, two completely different behaviors. Number 1. Jupiter, the limit of what we can understand. Finally, the largest planet in the solar system, Jupiter. We've sent probes, we've studied it for decades, and still, we don't truly understand it. Inside Jupiter, hydrogen becomes metal, a vast ocean of liquid metallic hydrogen, conducting electricity, generating a magnetic field thousands of times stronger than Earth's. And at the center, there may not even be a solid core, instead, a diffuse region, a gradual mix of heavy elements and gas, a structure that contradicts how planets are supposed to form. Temperatures reach tens of thousands of degrees, pressures beyond comprehension. Matter behaves in ways we cannot recreate, cannot observe, cannot fully model. Jupiter isn't just a planet, it's a boundary, the point where our understanding starts to fail. The most unsettling part isn't how strange these worlds are, it's how close they are. These aren't distant galaxies, they're right here in our own solar system. And still, we don't fully understand them. Not yet. And remember, the universe doesn't reveal its secrets to those who rush, it reveals them to those who know how to look. Subscribe and keep listening to the silence.